Okay, maybe I restart. Is that okay for everyone? Share screen. Share. Okay. Okay, so this next section on the course is on visualizing data. So maybe should I say a bit about it? Like I kind of believe that this is a good way to learn R. Like if you can kind of go through the basics from the last slide, and maybe forget about the sort of programming parts. But if you can understand sort of the basics between a data frame and a matrix and a vector, and sort of how to do some basic manipulations, I think the next step is usually to try out visualizing data. It's a really good way to sort of learn how functions work, and you can really sort of visually see the impact of changes that you make on your code and how they can be reflected in a plot. Maybe it's a bit easier to sort of get comfortable with programming going this route than rather than dealing with data frames. So we'll talk about a little bit later about how you can import data frames and mess around, sort of manipulate data frames. But before we get to that, let's talk about how to visualize data. So R has lots of different graphics packages. So there's many different ways to represent the data. And depending on sort of a specific discipline or specific area, there might be a very particular package that just does sort of one type of plot that might be very useful. And there is also some sort of more general plotting packages. So the default one in R that's loaded, one of these 7 packages that are loaded when you load R is the graphics package. And this has many plotting functions that we've already seen, right? I did the plot function and the histogram function before. So these functions in the graphics package, they are kind of fairly simple, and they're actually not too consistent, right? If you go to a different plot, then you get different looks. So just to give you an example, I'm using some data from the UN. So we have the country names, the region names, the area names, the infant mortality rate, total fertility rate, the sex ratio, and then the UN's definition of whether it's a less developed or more developed country, and from the UN policy data set on whether their population growth policy is to lower, maintain, or increase, I think. So we're going to use this data throughout these slides. So just to give you an example of these basic graphics package in R, we can do the plot, right? So here we're plotting the data. I've saved it as object D. So every time I use D, it's really the data that I imported. And so here I'm using the data frame D and the column infant mortality rate, and I'm plotting that against the total fertility rate on the x-axis, on the y-axis, sorry. So you can see here we have on the left we have a scatter plot, and on the right we have a histogram. And they look slightly different. Like when we do a histogram, we get a title, but we don't get a title when we do a scatter plot. And you can see the axes are a bit different. Here we have like a box completely going around, whereas the style is a bit different for the histogram. We sort of have these broken axes, and it looks a little bit different. And within the graphics package, there are more functions to do lots of different types of plots. But I'm not going to really focus on that. I'm going to focus on the ggplot2 package, because this is really probably the most popular now package, I would say, to do plots in R. And it has lots of nice features about it that are probably a bit advantageous in compared to the basic graphics package. So this ggplot2 package was developed by Hadley Wickham. I think he was doing his PhD. He is now I'm not sure if it's the title, but he works for RStudio, maybe the chief scientist there. And what the package does, it builds on a book that was called The Grammar of Graphics. So it really implements this grammar of graphics into sort of a coherent system for describing and building pretty much any type of graph, right? Any type of plot. I don't know about that. I mean, so it provides like very versatile sort of functions to create lots of different plots using a sort of consistent approach across different types of plots. So once you kind of learn the structure of of how the code works, and you can really change to a different type of plot quite easy. So to learn this, maybe there's a bit of a learning curve to sort of learn the different, at least the grammar and how it works of the functions. But once you sort of get an idea of the learning system, it means you can have a very sort of flexible way to create many different types of plots that, and yeah, many different types of data situation that you can't really get from like just learning all the different functions in the graphics package, because they all work slightly differently. There's not really a consistent system to them. Whereas the ggplot, there is this sort of a nice grammar that goes across all the different functions. So to load the ggplot package, we can do library ggplot2, or we can do library tidyverse. And I recommend we start R, and after starting R, the first thing we do is to do library tidyverse. This is going to load the ggplot2 package along with some other useful packages that we're going to talk about later. So underlying the ggplot2 package is, like I said, it's based on this grammar of graphics. And this is the idea that you can build a graph from the sort of same set of components. And that is these three components here, that you have a data set, and then you want to transform this data onto a coordinate system, and you want to represent the data on the coordinate system using some geoms. So these might be some sort of geometric shapes, right, that visually mark the data on the coordinate system, and this will give you the plot. Okay. So we're going to see the term geom quite a lot, and maybe a bit the coordinate system as well. Okay, so within this system, right, before we had data geom coordinate system, we also can, whenever we create a plot, we might want to give some definitions on the aesthetics of how the geom might look. So in this case, we're using points, right? We're representing each data set with a point, and we might want to change the color based on some column, right? So here we're saying the column is based on the values in F, and the size of the point here we might want to change depending on what the value is in column A, right? And of course, we need to define what's going to go on the X and the Y axes. So this might be based on column F and A, for example. Yeah. So underlying this ggplot, to sort of transform this idea of a grammar in a graphic system, we can ggplot has this sort of basic sort of template that we could write pretty much any type of plot using. So the idea is that we always sort of start a ggplot using the ggplot function. So we write ggplot, and we give it the data set, right? We always need to give some data when we're creating a plot. And then we also will create a geom function, right? So not create a function, use a geom function. That's on that geom function, we will define a set of mappings, right? So this is going to tell us what's on the x-axis, what's on the y-axis. So this is going to link the data to the geom that we're creating. Remember, the geom is how we're representing the data. So it might be a line, might be a point, it might be a bar, right? So in this case, the geom will change. So these three elements, the data, the geom function, and the mappings, every ggplot we do, we need to define each of these three. These other parts are flexible, and usually they have like nice defaults, so we don't need to change them. But we will still go through just to show some examples of what happens when we do change them. It can change like how the plot looks, allow us to create multiple plots, for example, or change the sort of symbols that are being used. Okay, so here's just a quick example of the sort of equivalent ggplot versions of the two plots that we saw before in the base graphics package. So you can see we load the tidyverse first, which loads the ggplot package. Remember, you have to install tidyverse before you load it, just a one-time install. Okay, and then we give it the data set D, right? So we always put the data as equal to D in this case, because that's our data set. And then we put mapping, and then we give AES, right? This is the aesthetics AES stands for. So on the x-axis, we want the infant mortality rate column. On the y-axis, we want the TFR column. And then we want to represent this data using a points. So we use geom point. Okay, and then in the second, on the right, we're just plotting the TFR data, and we want to represent the TFR data using a geom histogram, right? Using a histogram, so it creates a histogram. So you can see here, there's a sort of a bit more of a consistent style between these 2 points, 2 plots, right? We both have this kind of gray background, and it's all in a sort of square. Here we've got we don't have a title for the plot, but we have each of the axes are labeled depending on the columns that we're using. And we can also see in the code, right? We haven't before, when we did a scatter plot, we'd have to write $, IMR, $, TFR, but here we only have to write the data set once, right? So we don't have to keep repeating ourselves when we're creating the plot, ggplot. So what is actually happening with this this sort of set of code, right? So the ggplot function, we can run that on its own, right, and without the geom. And what that will do is set up a coordinate system to add layers to, and then we pass the data to the ggplot. So we could pass like the data, the Swiss data, for example, and that's just going to create like an empty graph that it's got nothing plotted on it, right? Because we need to add a geom, right? A geometric representation of the data. So the geom function here adds a layer of points to your plot, and we connect it using the plus sign here. Remember, here we're typing plus, right? This is not like R producing that. Maybe that's can be confusing for starters. So we type plus at the end of the line, right? And then because we press enter, this plus appears here from R, right? This is R creating this plus. I type this plus, R creates that plus because we've gone to a new line, okay? So you only need to put plus once. Yeah, if you type it twice, it's going to get confused. Okay, so yeah, this is, we're talking about the geom functions, right? Where there are many different types of geom functions in the ggplot2 library. And each time we use a geom function, we're just sort of essentially putting a layer onto the coordinate system that we've created. And the geom function sort of links to the data using these mapping arguments via the aesthetics. So the mapping argument, yeah, explains where your points are going to go. And we sort of use the aesthetics function to tell us how we do that. So we can set the X and Y arguments in aesthetics to explain which variables in the data map to the X and Y axes of the plot. And the ggplot function then looks for those variables in the data set. And we can have different types of mappings depending on the geom. So you saw for here example, we didn't have a Y geom, a Y aesthetic, right? Because when we do a histogram, we only need one variable. We don't need to give it two variables. Okay, so within ggplot, like I said, there's lots of geom functions. So maybe there's around maybe over 30 in ggplot2. And there are also like additional packages that have been developed that create other geoms as well that aren't in the core ggplot2 package. So each geom is each geom function is suitable for visualizing different types of data. So on the next page is taken from the ggplot cheat sheet, which is in the handout folder, and it sort of allows you to quickly see all the different types of geoms and how we could represent the data. And below each of them is listed the aesthetics that apply to each geom, and the required aesthetics are in bold. Okay, so this is like I said, taken from the ggplot2 cheat sheet, and you can see all the different types of geoms here. And this is just what type of shape they're going to create. Yeah, so if you want to, let's say, columns, then we can use geom column. Yeah, and which one do we use? We use geom point just now, right? So this will create these points. Yeah, so after the geom, you can see we've got X, Y, alpha, color, fill, shape, size, and stroke. So these are all the different types of aesthetics that we can change in that geom. So you can see in let's see what's a good one to think about, like geom column. Here we have again we have something like we have a line type aesthetic that we don't have in point, right? Because in a point you can't have a line, right? So, but in a column you could have the line type on the border that you can control. So this is sort of telling you the different things that you can control about each geom. Okay, and you can see they all take common names, right? So it's not like color is always color, right? It's not called like shade or anything, or takes a different value on each of them. So this is these in the cheat sheet. They're separated by these are geoms to do with two variables. These are to do with sort of basic shapes, and then further down it's to do with one variable. So we've got like the histogram that we had with one variable that we were using, and this is when we have different types of two variables. So when one's discrete and one's continuous. And this is for three variables, right? So if you want to create some sort of tile plot or a raster or contour plot, then we can use three variables. So I'll give you a few examples of common ones that I use. So this is just what we similar to what we had before with the histogram on the right, and on the left we're using rather than use geom histogram, we're using geom bar. So when we do geom bar, it sort of counts in each category how many values there are, right? A simple bar chart. On another example, this is with the TFR, just like the histogram data. So again, one variable, but this time it's continuous. So we're using geom density. It plots this smooth like density line. Frequency poly, it creates this sort of line that's linking up the frequency of the TFR at each level. So it's sort of a less smooth version of the density plot. This is where we've got two variables. So in this case, we've got the scatter plot that we had before, but and then on the right we have a 2D density, which is kind of like a contour map of the points. Yeah, so a different way that you might want to visualize the data. But again, we're using exactly the same data, exactly the same variables. We've just changed the geom. Yeah, this is the only thing that we changed, how we represent the data. There's some other examples with two variables. This time, rather than both continuous, one is continuous and one is discrete. We've got the continuous TFR and a discrete growth policy. And here we created some box plots, and here we created some violin plots. Yeah, so we did that using geom box plot and geom violin. So again, everything's the same on the first line. It's just on the second line we use a different geom to represent the data. And then just some more examples using sort of time, so creating some time plots. So here I've just created a subset of the data frame for China, looking at the infant mortality rate and the total fertility rate over time. So here we've used a geom column. So we put time as the mid period. Let's see here. This is the mid period here column. So we use the mid period and then the TFR. We use a geom column to put columns in each of the periods, and here geom area to create this sort of area plot over time. So same data again. Everything on the first line is the same. It's just the geom's different. And then two more examples. This one's using geom line, so just connecting the points over time. This is using geom step, using sort of these steps to move between the points. Okay, and the last is just a sort of more technical example of the difference between geom line and geom path. So I'm going to use geom path later in the data set because it's a nice way to sort of show how data evolves over time. So when you use geom line, here we've plotted TFR against infant mortality rate, right, on both of these plots. And when we use geom line, the line just connects the points going left to right. You can imagine it's like a printer, like slowly printing across, right? It's just connecting the points up as we go across. And geom path differs from that. Geom path follows the order in the data, right? So it's better for showing changes over time when you don't have time on a particular axis. So in this case, right, the first data point is up here where in the 1950s, where TFR is high at 6 and infant mortality rate is at what, 125 maybe? And then the next point, the TFR decreases, and then it increases again, and then infant mortality rate drops, and then both infant mortality rate and TFR drops, right? So you can see on the first line, on both of these, they're exactly the same, right? We're using the same data. The geom path is following the order in the data set. So that's why the line looks different. Whereas geom line is just plotting like left to right. It doesn't care about the order of the data. So geom path is a nice sort of geom to sort of show it, the evolution of relationships over time. Okay, so that's sort of a basic on geoms, and we'll talk about a little bit about layers next. So geoms essentially are layers on top of a coordinate system, right? And we can add more than one geom at a time if we like. So ggplot allows us to share the data and the mapping aesthetics that we use in the ggplot function by all the geoms that are used afterwards. And we are flexible enough in ggplot that we can overwrite individual geoms by placing them in the mapping arguments of the specific geom functions. Maybe it's a bit technical, we can understand a bit better with a demonstration, okay? So this is what we mean by layers, right? If you remember before, we sort of saw these blue lines and the points, but they were on separate plots. If we want to put them on the same plot, then we can just create two geom layers, right? So we do the ggplot function, and then for each of them, we're going to use the TFR and the Y on the x-axis and the infant mortality rate on the y-axis. And then we're going to plot a density, 2D density, and then we're going to plot the points. Yeah, so this is creating layers on the points by using two geoms rather than a single one. Okay, and as I said before, the geoms are sort of sharing the data and the mappings from the first function, the ggplot function, right? And if we want to sort of highlight a specific point or use a separate data set or a separate mapping, then we can do that within the geom function itself. So in this one, I add a third layer, but rather than using the data that we used for the previous two geoms from the whole of the data set, here I'm just going to use the 14th row of the China data. So let's go back to the China data so we will remind ourselves. Okay, so the 14th row is just the last observation here. So I'm just going to use this last row as the data rather than the whole of the all country data set that we're using for all these other points. And I can also specify on this geom, right, the point I'm just going to put as red, right? So this allows us to highlight in this layer a specific point, right? And in this case, it's for the China data, yeah. And I've highlighted it using a different color. I'll talk a bit more about the aesthetics very soon. Okay, so when it comes to layerings, there's some other useful geoms. So one is geom H line and geom V line. So these allow you to add horizontal or vertical lines that can help sort of illustrate your story that you're trying to tell with the plot. Or you can add this AB line, which is where you put like a straight line going through with a defined intercept and slope argument. And again, we can sort of use them, define these arguments within the mapping argument. So it's just an example using the plot from before, but without the China point. And here we put a geom vertical line at 2.1. So this is like what replacement fertility level. And we put a horizontal line at what is this? This is the average infant mortality rate. So we use the mean function on the infant mortality rate column. And so we can apply it straight into the mapping here. So maybe I should comment about this, that you see on the V line, right, we give it a single value, yeah? So in this case, I use x-intercept, but I don't use it with the mapping equal to AES, the aesthetics, right? Because it's just a single data point. If I want to use on the aesthetic, right, the intercept, in this case, the y-intercept, if I want to use any part of the data, then I have to use this mapping is equal to AES, right? Unless I work it out separate from the ggplot code. But yeah, if you want to use the data when you're defining what the y-intercept or anything, any type of aesthetic, then you need to use the mapping function to do that if you're using part of the column from the data. Okay, so at that point, I would stop the class and we would take a good 30, 40 minutes to do some ggplot code. So maybe I explain a little bit about when you come to do this, that you need to load the tidyverse package first. So you need to make sure that that's installed, and then to use the source function. So maybe I just show this in RStudio. So let's go back. So I would load RStudio, open RStudio using the project file, and then it's going to be able to load the data from the correct place. So double click on that, and then it will open up RStudio. Okay, and then I would go to the exercise file, and this time it's exercise 2.1. Okay, and so I would just check that I'm in the right place using this part. So this is the directory I want to be in, right? The handout folder, and then I would load the tidyverse. I think this is a tidyverse. Okay, So it will just give you a sort of welcome message when the tidyverse is loaded. Okay, so there it is. And then we source this file. And what this file does is just load the data that we're going to use in the exercise. So there's a message just saying the data for the exercise should now be folded. And you can see it's appeared up here. And this means we can then look at this data. And then for the questions later on, we're able to sort of create a scatter plot. So we're going to do ggplot data is equal to D, and then mapping is equal to AS. X is equal to, so it says infant mortality rate, so I can see it's IMR, and Y is equal to, let's see what the question is, total fertility rate, right? And it's a scatter plot, right? So I know I want genome point. Okay, so it would be, oh, I don't know why, okay. Okay, so then you can sort of go through the questions like this once the data is loaded. Okay, so it's important that you do this source function and that these appear correctly. And if you're not in the correct location on your computer, then you'll struggle to do that. So again, remember to load up RStudio using the how do we call this? The R project folder to launch RStudio. Okay, so that's the first ggplot exercise. Okay. So, okay, so the next sort of part of ggplot to think about is groups. So many of these geom functions use a sort of single object to describe all the data, but we can use this group aesthetic in the mappings argument to use a discrete variable, so like a categorical variable, to tell us to separate the geoms, to create multiple geoms for different groups of the data, different sort of subsets of the data. Yeah, so this will allow to draw unique separate objects for unique values. Okay, so this doesn't add a legend or any distinguishing feature to the plot to detect which groups we're using, but we will later see how to do that using other type of aesthetics like color or line type. Okay, so here we're just going to focus on a subset of the data for East Asia, like created and saved in a separate object. And then show you how groups work. So this is without a group, right? So if we plot the East Asia data, and then we do geom point, and we get all the points, and we do geom line, you can see again, line is just working by plotting like left to right and connecting all the points up. So it's not really a great plot, right? Because we're not quite sure which country is which. So this is where group comes in. It helps us create a separate geoms, or separate the geoms for according to some kind of grouping variable. So in this case, we used a variable called name in the data. Let's go back to that. So name is the country name. Okay, so we're going to use the country name to create and pass that into the mappings argument via the aesthetics function. So we're going to say for each country, we're going to want to plot their points and the line. So this creates the separate lines for each country rather than putting a line through all the points. It's now aware that there's some sort of grouping structure to the data that it can be used to plot the points. Okay, so beyond group, there are some other aesthetics that we can change. So for example, we sort of talked a little bit about this before, that we could change the shape of a point, the line type being used, the size of the object, the color or the fill. So these can be a bit confusing, but the color is like the border color of the object. And when we have a one-dimensional object like a line, then we usually can use the color, but we can't use the fill. The fill is for like the internal color of the object when it's two-dimensional. So like for a point, we can define the color, which is the border color of the point, and then the internal color of the point using the fill. We can make them different if we want. And then the alpha, I like to use a lot. It's like a value between 0 and 1, which is telling you how transparent the point is. And there's other aesthetics as well, but these are sort of the most common types, I would say. And again, they're all on the cheat sheet for each geom. So not all the aesthetics are going to work with every geom. So for example, with geom point, it has no line type option, right? Because you're plotting a point, and so why would you want to, how could you control a line type? So yeah, on the cheat sheet, we can see what's available. So we can set the aesthetics to a single value to change the appearance of all the plotted objects. and we can put it outside the mapping like we did before for the x-intercept example, or we can do it for set their mapping to a given column in the data by putting it inside the mapping, the aesthetics function. Okay, if we want to set the variable names in the data, we need to sort of, if it's discrete, it's going to operate by each category. And if it's continuous, it will operate along a scale of the range, in the range of the variable. Okay, and again, not all aesthetics can be set to continuous variables. So like we couldn't give a line type as a year, because a line type has to be sort of a categorical, a discrete number, an integer number. So we can set different types of aesthetics to different types of variables. So maybe that's easier to show in the actual example. Okay, so here we are. We've done the scatter plot like before with the X and Y, and this time we're changing the shape so we're giving different shapes to different countries. And when we do this, we see it's not really the best option, that there's only 6 shapes plotted, and then 7 and 8 it doesn't. And actually it plots a warning message saying if you're using shape and you've got more than more than 6 categories, you should consider some other aesthetic. Okay, so in this case we change the shape and we put color. In this case it creates this how do we say, legend guide for the different countries based on the different colors based on the different country names. In this case, we put the color to the mid period, right? So it's a continuous variable. Here it was a discrete variable we used for color. Here it's a continuous variable, and then we get this sort of continuous range going from 1960 to 2020. And you see that lighter points are the more recent points, and the darker points are the older data. Okay, this is using a geom point and geom path, using a combination of color and line type, right? So we can specify multiple aesthetics at the same time. So here we can sort of see the China data again, how it evolved over time, moving towards the bottom left-hand corner. And in this case, we got the color, and rather than line type, we use the alpha. And so the alpha, remember, is sort of the level of transparency. So we sort of see the older data is sort of more, how do we say, more see-through, and then it gets clearer as we get to the more recent data. And this part, this is just a fit. By default, the guides go underneath each other, which don't quite fit on the slide. So I changed one of the defaults to put them side by side. And this again is just another example where we've got the color for the country name, but now we set the size of the point according to the population column, and we've divided the population column by 1 million, which we can type as 1,000,000,6 zeros, or we can write 1E6 in R, and it's the same as a million. And we get this population scale as well on the size of the point, so we can see the Chinese data, the bigger points here. And here, for the geom points, rather than set the transparency based on the time, I set the transparency to 0.5 for all the points. So you can see it's not, I don't use mapping and AAS and the aesthetics because I'm setting it for all the points. So in this case, I set it to a single value for all the points and put it within the geom. Okay, so that was the aesthetics. And then the next part to talk about, actually, let's go back and remind ourselves of the grammar. Where were we? So remember the basic common template, right? So far we talked about the data, and we've talked about the different geoms, and then we just talked about now the different mappings, right? So get an idea of these 3 sort of required parts of ggplot code that we need to provide to create a plot. Okay, so the next part we're going to talk about is the position, one of these optional parts, right? So after these 3, well, for each geom, there are sort of 3 main arguments, right? Inputs that are required to create the geom. The first is the mapping that we define, and then the second is the position, and the third is the stat. So both these position and stat, usually they have a default for them, and most of the time we really don't need to worry about what they are. But for the position, well, what position is doing, it's adjusting or or sort of determining how we arrange the geom that somehow occupy the space. So like I say, for most geoms, we're unlikely to want to change the default, but maybe for geom bar, it's useful to see how it works, because it can allow you to create different types of bar charts. So for geom bar, there's 3 different types of options for the position. So one is stack, one is dodge, and the other is fill. So we'll see visually later what they're doing. For other geoms, there are other different types of position possibilities. So 2 examples are a jitter, which adds some random noise when you've got lots of points on the same place and you're using geom point. Sometimes jitter can be useful. And nudge allows you to sort of shift things over to a given sort of X or Y direction. And so, for example, in geom label, that can be useful, but we won't go into too much detail now. So just an example of positions with a geom bar. So like I say, when we do geom bar, by default, inside geom bar, it's written position is equal to stack, which is what's happening here, right? Like I mentioned, stack. Okay, so when we do geom bar and we've got the X, and then we've added this fill as the continent, the area name column in the data frame, then it's stacked the bars on top of each other. Okay, so this is sort of the default of how it arranges the bars. When we change the position from the default of stack to dodge, then we get a different type of bar chart, right? Where we get these separate bars where they're sort of, rather than being stacked, they're put side by side. And so we get these sort of groups of bars for each of the policies. And the third example, again, in each of these, right, the first line is the same. We're just changing the geom bar away from stack, then to dodge, and this time to fill. And in this case, it like sort of creates a sort of percentage amount within each category, right? How many of the countries are in what share of the countries that want to lower their populations are within Africa, within Asia, and so on for the rest of the continents. So it really can change the look quite drastically, and this is probably with geom bar. This is really the only main geom that it's useful to know about the position and changing the position argument. So, like I said, the third part of well, maybe let's go back to which one was it? The template. Okay, so we just talked about the position, and then we're going to talk about the stat, this other sort of optional thing that we can change. Okay. So each geom, like I said before, right? Each geom has these 3 main arguments: the mapping, the position, and stat. So what the stat argument is doing, it's building a new variable to plot. So it's short for the statistical transformation. So you imagine this is our data, right? And we want to do a plot like a histogram. What is actually being plotted, right, on the y-axis is how many variables fall within some category on the x-axis. So underlying the plot, it's the data is not coming straight. The data that's being plotted is not coming straight from the data. There's kind of like a mid data set that's based on some transformation of the data that's sort of creating a variable x that's going on the bottom axis, and then a count within each category to create the count variable that's going to be plotted here. And that sort of mid-level data set is the one being plotted, not the original data, right? So this stat is applying a transformation and storing the results sort of behind the scenes. And like I say, usually the stat is giving a very nice default that we don't really need to play around with. So we really need to adjust it. So just to give you an example of how it works, so rather than knowing how to tweak it, so these are sort of some of the different types of stats that are used. So identity just means we use the raw values, and the transformed data is exactly the same as the original data. The count data computes 2 new variables, the count and proportion. So remember when we did geom bar, let's go back to here. You see what's plotted here is the count, right? The count. So the count is not a variable in the data, and it's created that subset sort of hidden data set that's counted how many countries there are in each of these categories, and each of these, or a combination of the categories of the growth policy and the continents. Yeah, so this is for working out the count of the proportions. The histogram, it's using a bin transformation to sort of bin create separate categories for the continuous variables. Let's not go through all of them. Maybe the box plot is useful, right? So when we do a box plot, we're not plotting straight from the data. We're working out what the minimum, the maximum, the interquartile range, and the median is to actually plot for the GM box plot. Okay, so just to give you a better feeling of how it's working, we will again look at GM bar. So imagine we took the China data, and then we wanted to plot on the bottom the period, and on the y-axis the infant mortality rate. So if we set that up and then did GM bar, we get an error message. It's not going to plot. So maybe we could try and get rid of period, right, and try and put the infant mortality rate on the bottom axis. And in this case, what is happening is just counting how many observations there are in each of these infant mortality rates levels, right? So we're seeing there's 1 point at, what is this, maybe 30, or there's 1 point at like 55, 1 point at 70, right? So it's just counting the observations, which is not really what we want, but that's because the default for GM bar is to count. So if we wanted to, rather than to do a count sort of statistical transformation of the data, and we wanted to instead to take the actual data itself, then we can define the identity stat. And that's saying just take directly from the data. Don't worry about counting how many observations there are at each infant mortality rate. Instead, just take the value of infant mortality rate from the data. So this is what the stat transformation is doing. And that allows us to build a sort of time series plot of the counts using bars. Of course, GM column is actually the better way to do this. I mean, it's not super obvious, I shouldn't say, of course. But yeah, GM bar is GM column is in fact GM bar with stat is equal to identity. It's pretty much it will give you the same result, right? So in this case, GM column is a better way to do it. But I was just sort of showing this so you get an idea of how the stat works if you really need to know. Okay, so the second exercise is just plotting with practice. Again, you need to sort of source the preliminary code to load the data, and then you're able to try and practice doing different layers of plots and changing the aesthetics and messing around with the position mainly. Okay, so let's continue with the coordinates. So let's go back again to this one. Okay, so we've talked about the data, the geoms, the mappings, and a little bit about the stat and the position. And we're going to talk about these final four kind of optional parts in the remainder of the slides. Oh, I clicked forward too much. Stats. Okay, here we go. So when ggplot, by default, when it sort of creates the surface to plot on, it uses sort of this Cartesian coordinate system. But if we want to, we can sort of use a different coordinate system, which can really change the look of the plot quite dramatically in some cases. So these are sort of the other types of coordinate systems that we could use. So coordinate flip, for example, is just going to flip the x and y coordinates. So what was x becomes y and so on. Coordinate transform allows you to add a sort of transform the coordinate system from Cartesian to perhaps a square root or logarithmic axes. We could do this using chord trans. We can sort of fix the ratios between the sort of the how would say the height and the width if we want, and we can also move to a sort of circular plotting system using chord polar. So there are a few examples of that in action. Okay, so this is a plot with the East Asia data, the infant mortality rate against the total fertility over time. Again, using different aesthetics for the different countries and the time. And here I'm using chord fixed and put the ratio as 0.05. So this means for one coordinate unit of infant mortality rate is same. It's going to take the same length in measurement as 0.05 of the TFR. Okay, so if we go up, how would we say, like if we go up one infant mortality rate, it's the same as going across 0.05 in TFR. And yeah, so this is just a fix the ratio. In this case, we're flipping the coordinates. So before we had the TFR on the bottom, and the infant mortality on the horizontal, on the vertical. This time they're switched around. And then this is to use a log axis, right? So we transform the y-axis from a sort of standard Cartesian sort of system to a logarithmic system. That's good when you have outliers. And then finally, we've got a polar plot, and this is where what was on the x-axis is now the angle in the circle. So that was the TFR, and what was on the y-axis on the coordinate system is now the distance from the circle. Okay, so the further out they are, then then what is it? The higher the TFR, and then the sort of angle that they are at. So like where they are around the circle is based on the infant mortality rate. Sorry, the total fertility rate. Okay, so yeah, the final sort of main usage for polar coordinate systems, I think, is to really create pie charts. And so in ggplot, to create a pie chart, there's not a geompie, right? But it's really thought of that a pie chart is really like a bar chart, but put on a circular coordinate system. So in the first plot here, it's from the first code, right? We just do a bar chart on the growth policies, yeah, and then we get the different heights of the bars, and we can change that to a single bar by setting the position is equal to fill, right? And then we can this sort of stacked bar chart. So a pie chart is really this stacked pie chart, but put on a polar coordinate system. So again, we just got the same. So this was the second plot to create this middle one. And to get the one on the right, we take what we have on the second plot and then just add the coordinate polar system to it and set the theta, the angle to the y value, which in this case is the count. So it turns in, which is really a proportion. So then we get the pie chart out of this. Okay. Okay, so that was the coordinate system, and like I said, there's four of these other optional ones. So probably the most useful one to know is the facets. So facets divide the plot into subplots based on values of one or more discrete variables. So they can be a very effective way to compare across different categorical values across different categories. And there are two sort of ways to do facets, two functions. One is facet wrap, which sort of works when you're just using one categorical variable. And the second is facet grid, which allows you to create like a matrix of plots based on two categorical variables, sort of cross-classification of the data. So in each of them, you need to define which variable is going to be used to create these different facets, these different windows. So when you use facet wrap, you can sort of define it as a specific variable, or you can use this vars format. So this is saying using the variable A to define the facets. In facet grid, we can cross-classify the data, right? So we can use the variable A for the rows and the variable B for the columns. And then there's some other arguments. Maybe I will go through these in an example, be a bit clearer, but we can define the number of rows and columns. We can define whether the scales are going to be fixed or free, and we can adjust the labels for the facets. But maybe let's show a facet plot to help us understand a bit better. So in this case, I've done taken the East Asia data, plotted on the x-axis the mid period, on the y-axis the TFR, and then the color is the name, right? I've done the GM point and the GM line, but I've created these separate windows for each country by using facet wrap, right? So this is a facet, right? Kind of a little window for each country, and we've created that by setting facets is equal to name, just like we put color is equal to name, but in this case we have to put it in quotations, right? So this is just what is required when we use facet wrap. Okay, and this creates these separate windows for each of the facets. So this again, these first three lines are the same as the previous slide, but here rather than put facets equal to name and quotation, I use facet vars name, which is the other option to do it. And then I change some of the optional arguments. So in this case, I put the number of rows is equal to 1. This puts all the facets on the same row. And I use this labeler. So this can be useful for when you have long country names, then you can use the label wrap gen, and this makes sure after the 15th character, wherever there's a space, it's going to create a new line for the label. So this is what's the difference between, you can see like for Korea or North Korea, that the name was not completely appearing here because it's too long. Yeah, so this sort of wraps the label of the name to be no longer than every sort of time there's a space after the 15th character, it creates a new line and some extra space to fit the label in. Okay. So this is again another example where the first 3 lines are the same. We use facet wrap, facets var is equal to name, just like we did before. But now rather than having one row, we just sort of leave the rows to be worked out automatically. But we set scales is equal to free y. So what does this do? So you could see back here, the scales were all the same, right? They were all based on scale going from 0 to around 8 for the TFR. In this case, we put the scales for the y-axis to be free. And this means for each facet, it decides based on the data within the facet on what the range is for the y-axis, right? So for Japan, it's only going between 1 and 3, right? Because of the way the data is evolving, whereas China, the range is bigger because the drop has been larger in fertility rates. Okay, and this last part, maybe I didn't mention, it's guides. This is turning off the legend, right? Because we did this here as well, right? We were dropping the guides for the color. So this was appearing here, but we really don't need it because we already got the labels in here for the facets. Okay, so another example of facet wrap, but rather than using the facet as the country name, we're using the facet as the continent. And rather than doing a line plot, we do a scatter plot. And this time we're using TFR against the infant mortality rate. And the color for the point is based on the country name. So you can see the different relationships. So you see we've only got the USA and Canada and North America. So you can sort of see these relationships. And then this is using, again, a different way to facet the data. So rather than use the continents, we're using the definition of the UN's definition of developed and less developed and more developed countries. And then this is just to show how the scales work. We could write free y, we could write free x, or we can write free. And when we write free, both the y and the x-axis are free. So that means it creates these axes depending on the data within it. So rather than getting all the data like clustered up here, clustered down here for the more developed countries, because it's really based on the global sort of axes. On the less developed countries, we can get their own separate axes on each, which allows us like a bit of a zoom on the more countries. Okay, so everything before has been facet wrap. Like I said, there's a second facet function, which is facet grid. And this allows us, rather than classify the data by one, like before we were just talking about continent or country or what was it, less or more developed. With facet grid, we can get this cross classification. So in this case, for the rows, we use the developed, like we used before. And for the columns, we sort of cross classify the data by the growth policy. And again, we're just using the scatter plot of infant mortality rate against TFR. And so you can see there's only one country that's a more developed country that wants to lower its population. Yeah? And yeah, there's a few in this case. Okay, and then we can get really complicated if we want. So again, here we're going to put the scales to free, which sort of sets the scales depending on the row and the column value. So it's not quite the same as the free scales in the facet wrap. And here we're going to put the labeler to make sure that the labels all fit in. And then this last bit, I always forget that. I always have to Google it to find out. But this is to rotate the text. So if you see back here, we've got less and more on the strips here, the strip text. We can rotate that round using this little bit of code that I always forget to do. So within theme, there's hundreds of options to change all these different little bits of the plot to change the look. Okay, so exercise 3 is really just to practice with facets. So again, I would take some time to go through this, maybe a good 40-50 minutes to try and practice working on these different parts of the data. And and then finally we just go through the finishing touches. So maybe I flick back just one more time, maybe to the template code. So here we talked about the coordinate system and the facets, and then we just got 2 more to talk about the scale and the theme. So the scale, there's many different scale functions, right? So they all take they allow you to sort of change the aesthetics from the default. So whatever the aesthetic might be, whether it's the fill, the x-axis, the y-axis, the shape, the size, we can manipulate all these, and we do it using the scale functions. So they all take a general form that we take a scale underscore, and then whatever the aesthetic is, and then continuous or discrete depending on the type of data that they're using. So maybe it's a bit easier to see from the examples. So here we're just taking a ggplot, and by default, right, when we fill we're using the fill for the color, we're using a blue palette, but we can sort of change the palette that we want to. And we can create different palettes using these distiller or gradient functions. This is for the shapes. So we can change the shapes if we want to different values. So by default, R sort of sees this table to look up the different shapes. And when we do ggplot, the first shape will be a circle because that's one, and the second shape will be a square, and then a cross, for example. But if we wanted to change the shapes, for example, if we wanted to be the first one would be a cross, then we would put scale, shape, manual values go from 3 to 7. And then rather than starting at 1 and going onward, we would start at 3 and go onwards. This is just to change for points, just change the radius or their area. Okay, a few more examples in practice, okay. So I talked about this briefly, this palette is equal to blues for the scale, right? And blues is like a color set that's loaded when you load ggplot2. In fact, it's in a package called Color Brewer. And there's a website for Color Brewer where you can see these different palettes that exist. So the default for a continuous variable in R in ggplot is this blues line here, right at the bottom of these sets, right? But if we wanted to change it to like oranges, then we can just write the palette is equal to oranges inside a scale function. So here's an example again with the TFR data over time. So we're just filtering, though I'm not doing all the countries, right? I'm getting rid of Hong Kong, Macau, and Taiwan. And then I'm again putting the point and line, and then I'm really changing some of the scales. So for the color, I'm using the palette dark 2. So if we go back to here, we see we've looked at this dark 2 palette, right? So the first color is going to be green, then a brown, then a purple, and then a pinky, and then another green, for example, okay? So this is where I get the different changing the colors. For the shapes, I'm taking shapes 21 to 25. So you can see these shapes, they all have, they're kind of empty, right? There's a circle and empty square. And that's because we're up here, right? We're choosing shape, 21 to 25, right? So we're using these last 5 shapes here to create these different shapes. And then we're also changing the scale of the Y variable. So remember when we plotted these before, we haven't had so many labels. And that's because we changed the breaks. And the breaks is telling us where to plot these axes labels. So in this case, we want the breaks to go from 1 to 8 by 0.5. So it starts at 1, then every 0.5 it's creating a break, right? So we can modify this aesthetic, right? This Y aesthetic using the scale Y continuous and then the breaks argument. Okay. Here's another example, but changing using the fill gradient. So here we've done a tile plot. So here we've had to define an x-axis as the time, the y is the country name, and then the fill is the sex ratio of birth. Yeah? And then we've created a gradient of colors ourselves rather than using this default blue. And we're saying we're going to go from a pink to a blue, and then we're going to go through a white. So the white is going to be the midpoint, and we're defining the midpoint as 1.05. So the more pink it is, the sort of more female babies, the more blue it is, the more male babies at that particular time in that particular country. And we see we get this scale produced for us. Okay, so that was the scales functions, and then the labels. So far, if we see here, the labels that have come on have been taken directly from the data frame, from the column names in the data frame. And so, of course, we want to probably change them to make them more readable. So we can use the labs function. And the labs function has arguments for the title. So we can put a main title on the plot, a subtitle on the plot, a caption on the plot, which is down the bottom, And then we can put titles for the x-axis, the y-axis, the fill, the color, or any of the other aesthetics that are produced. So here's an example of like a nearly final plot, right, where we put the bar chart that we had before, the stacked bar chart. And rather than having count, for example, on the y-axis, we put the countries. Yeah? Well, we put number of countries. Yeah? And the fill, rather than saying area underscore name, we put continent. And then for the title, I put like a main title, a subtitle, which might be a little sentence about the main sort of takeaway. And then the caption might be the data source that goes down here. Okay. And then the last sort of thing that we could tweak in ggplot is the themes. So the themes tell you about the kind of overall look of the plot. So by default is this gray theme. This is what's used by default and why we have that gray background. But if we want to change that, we can use a black and white theme, or we can use a dark theme, or these other ones. And there's some other additional packages like GG themes that give you tons of other themes as well. So here's just the plot before without the titles, the labels, but we changed the theme to black and white. So remember back here we have this gray background, and then here we change it to a white background. Okay, and then the final bit for ggplot is to save the plot. So we can assign the plot to save it as an object if we want, which we can then later update. So here I'm saving as an object called ggplot, which is just the bar chart. And then if I want, I can have a look at how that plot looks with a different theme. And then we can use ggsave to actually save it outside of an object into an actual file. So ggsave, we require a file name. So we can give it a file name, and then we have to give the, how do we say, the file extension that we want to be saving as. So we can save it as a PNG or a PDF. So it's like an image file or a PDF. And this is going to be saved straight into the working directory that we're working on, or we can use the dot and then the forward slash for the folder that we want to put it on if we want. And then we can tell it the width and the height and the units that we are using to define the width and height. And then the scale. I'll show on the next page what the scale is doing. And when we do ggsave, it's going to take whatever plot is being shown in RStudio at the time. But if we want to take a plot that we saved before, we can also define that. So this is taking the plot G with the black and white, without the original G here, without the black and white. So here's just an example of the scale, right? So in this case, this is the PNG file from this first line. Yeah. So where we put scale is equal to 2. So you can see this is the text. Sort of all looks kind of reasonable. The ratio of the text to the actual plot. When we put scale is equal to 1, by default, in this case, with these dimensions of the height, the text is probably too big, right? We cannot see the labels clearly. They're all written over on top of each other. So by increasing scale, it sort of decreases the font, well, the text size in compared to the plot size. So it kind of gives you more room. And you can put scale between like 0 and infinity, right? So if you put it even smaller, like less than 1, it will grow the text size even bigger. Okay, then a final bit on combining plots. So far we've just like created single plots at a time, or maybe facet plots. But it might be that you have plots of different types that you want to combine. And for that, this patchwork package is very, very useful. So this allows us to combine plots using the plus or the divide to put them on top of each other. This is to put them side by side, or to put them on rows, we can use brackets. And then we can control the layout using the plot layout. So here I've just created 2 plots, right? One for East Asia and one for China. You see, there are different types of plot, right? This is a line plot. This is a path plot. And here we can combine them using G1 plus G2. So I save the first plot as G1 and the second one as G2. I can combine them, putting them side by side using the plus. I can put them on top of each other using the forward slash. And I can control the relative heights, right? So this is 2 to 1 using this plot layout function. And here we can really get very detailed about the layout by sort of defining the space that they are going to exist in. So here I've said the first plot should be in this sort of square here that's defined as A. And right up here, B on the top right should be the second plot. And this is to show an empty space here. So we sort of define this as layout, and we pass the layout to the plot layout function. Okay, so just to summarize, we got the cheat sheet, which is very, very useful to have printed out, especially when you're learning ggplot. So you have an idea of all the different types of plots that can be produced. So on the front are the geoms and the structure of the data, the structure of a ggplot function. And then on the back, the different types of stats and scales, the coordinate systems and the facets, the labels that we talked about, the position adjustments that you might want to worry about if you're using a geom bar, and the themes, and how to manipulate the legends, and a bit about zooming. Okay, so there's the final exercise. Again, this will probably take 30, 40 minutes, I think, this exercise. So yeah, it's good to always practice to really get familiar with how the code works. So again, I probably went a bit over, but let's take a break then, and a 10-minute pause again, and we come back to importing data.